Right, this is the video to go through chapter 1.1 on completing the square. In this topic, there are two learning targets. One is to use the technique which is completing a square to represent a quadratic equation. Now, to put it simply, actually what we're going to do is use the completing square method to rewrite a quadratic expression into a particular format, and the format is called completed the square form. Okay, so we are going to rewrite basically. Now, once we have learned how to rewrite, we will be able to use whatever that we got to solve. Okay, so if you think about it, we have done something very similar in Sec 2. Now, in Sec 2, you have also learned how to rewrite a given quadratic expression and then use that form to solve easily. Example. Okay, so this was in Sec 2. We covered this concept called quadratic factorization. And there was a particular method that you have learned in Sec 2, and that is called the cross method. Alright, so one example, x squared minus x minus 6. If you were to use the cross method, x squared, negative x, negative 6, x times x is x squared, 3 times 2 is 6, 3x, 2x. To get a negative x, I will need a negative 3 and a positive 2. And then, because of this technique, I managed to rewrite the quadratic expression x squared minus x minus 6 into a different format. Right? If you recall, this was what we did in Sec 2. Now, this whole idea is about rewriting a quadratic expression into an equivalent form, but definitely looks different. But what was the purpose that we did this topic last year? It was really for us to be able to solve. So last year, once you have rewritten the quadratic expression, you actually used it to solve an equation like that. X squared minus x minus 6 equal to 0. You will use the new form and write the left hand side as x minus 3 times x plus 2 equal to 0. And then from there, you can apply the zero product rule that says x minus 3 equal to 0 or x plus 2 equal to 0, and then eventually you could solve it. In other words, this technique on cross factorization enabled us to rewrite a quadratic equation, and using the rewritten form, we can solve it easily. So that was covered in Sec 2. We are going to do something very similar in Sec 3, topic 1.1. We are going to rewrite a quadratic equation into another form, and using that, we will solve it easily. And this technique is called complete the square. Alright, so let's begin by going through the first learning target. Let's do the rewriting first. And there are several success criteria. Okay, first we will need to observe a pattern, and then after which we will use the pattern to derive a formula, and then after that we will learn how to complete the square for various kinds of quadratic expression. So let us first start by observing a pattern. Let's turn the page. Okay, on this page, there are some things that we must first do. Okay, so to observe the pattern, these are the things that we need to go through. First, remember just now I said that in Sec 2 we learned about quadratic expressions that could be factorized into this format and then solve. Now in Sec 3, however, you will start to encounter quadratic expressions like this: x squared minus x minus 7. And no matter how hard you try, x times x is x squared, and then you try your very best, you somehow are not able to factorize it. And because you cannot factorize it, you cannot use your Sec 2 method anymore. So how are we going to tackle these kinds of expressions? Now, this kind of expressions that cannot be factorized are over here. Okay, please highlight. They cannot be factorized. So there must be a different way for us to rewrite. Right? Now, we will tap on the idea of perfect squares. Now, what are perfect squares? This is one example. This is another. Okay, let us observe the pattern. We will investigate how we will obtain perfect squares from a quadratic expression. So we're going to get something like this and this from the following quadratic expressions. The first one has been done for us. And if you notice there's a 1 square here, we will not evaluate the numbers. Just leave it as 1 square and 2 square for now. Okay, let's run through the activity. Activity 1, x squared plus 2x plus 1 square. And by the way, 1 square is just 1. If I were to factorize this using our set 2 knowledge, you will get that the factorized form contains of x plus 1 times x plus 1, like this. But we also know that x plus 1 times x plus 1 actually can be written as a square. Correct? Alright, so with that, let's use this same idea to factorize the next 3 questions, keeping in mind that the number 2 here actually is 2 squares is 4, 3 squares is 9, 4 squares is 16. Okay, to help you a little bit, I'm going to put down the terms inside the cross factorization table. And then after I've completed this, you can actually pause the video to complete part 1, part 2, part 3, and part 4. Give me a moment. Okay, so please use some time to complete this using the same technique as part 1. Okay, you can pause the video and get this done. Once you're ready, resume the video. Okay, let's resume the video. So if you have done it properly, let's check for everyone. So x times x, 2 times 2, both are positive, and the final answer for this will be x plus 2 whole thing squared. Now, by now, you should see a pattern. The next one is x plus 3 whole thing squared. And the last one is x plus 4 whole thing squared. Okay, let's move on to the second column, where it says make x squared plus bx a subject. Now, referring to our first example, we already know that the previous step gave us that we could rewrite x squared plus 2x plus 1 squared into the x plus 1 whole thing bracket squared. To make x squared plus bx a subject, now look at what I'm highlighting now. Let's make this part the subject. Let's make this part the subject. Now, if this is a subject, what should I do to the 1 square, the positive 1 square? You realize that I need to balance it to the other side, and it becomes a minus 1 square. Okay, so that's how we got x squared plus 2x equals to this. We have made it the subject. Now, by the same logic, let's try the next one. We already know that x squared plus 4x plus 2 squared from the previous table on the left side, it is equal to x plus 2 whole thing squared. Let's make the green color part the subject again, x squared plus 4x. So x squared plus 4x equals, okay, how should I balance the positive 2 squared to the other side? Now, if you do it carefully, you will get x plus 2 whole thing squared minus 2 squared. Let's do for the third one. X squared plus 6x plus 3 squared. We know that it is x plus 3 whole thing squared. And same goes to make x squared plus 6x the subject, this part the subject, I must balance the 3 square to the other side of the equation. So x plus 3 whole thing square minus 3 square. Okay, let's do one last one. Okay, let me highlight. So make this a subject, make this a subject. Okay, so now we need to observe a pattern. So do we see a pattern on this side? Do you see a pattern? Focus on this part, this part, this part, and this part. Now first, do you see then when there's a plus here, this is also a plus. Plus and plus. Plus and plus. Plus and plus. That's one pattern. Now second pattern, do you see that no matter which question we're talking about, there is always a minus here? Minus, minus, minus. That's the second pattern. The third pattern is, do you see that 2, you can divide by 2 and give 1? Divide by 2 and give 1? Can you see that 4, divide by 2 to give 2? Divide by 2? 6, divide by 2? Divide by 2? 8, divide by 2? Divide by 2? So, if you notice this pattern, what can you then say about the following questions? Can you write them down? What about x squared plus 10x? What is it equal to? What is x squared plus 12x equal to? In fact, let's go bigger. What about x squared plus 28x? What are they equal to? And to make matters a bit interesting, what happens if the number here, the coefficient of x, is an odd number? How can we use the same pattern to get the result for these 4 questions? Okay, can you try it? Pause the video, try it first. Once you get your answer, resume the video and check the answers. Alright, let's resume the video. Did you get these as your answers? X, 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 X. The first pattern says, I see a plus, right? So write a plus, 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 plus. So plus, 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 plus. The next pattern, this number, this number, this number, this number, every time we will divide by 2. So I will see a 5 here, close bracket square. A 6 here, close bracket square. A 14 here, close bracket square. And here, you write 5 over 2, close bracket square. Now please take note that here there is no x. You do not write anything else here. It's just a number. So do not write the x. Okay, next. The next pattern is, regardless of what you get for the 4 questions, it will be a minus, 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 minus. Followed by bracket square. Now what is in the bracket square? The number that you see here should be the same as this, 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 and this for each of these cases. So for the first question, I should see 5. Next question is 6, followed by 14, followed by 5 over 2. And actually what you have just done is to complete the square. So I can conclude something, you know. What is the pattern that we can see? The pattern is this. If you are given a quadratic expression, of the form x squared plus bx, okay? Whatever number the b is, you can rewrite it as bracket x plus minus bracket square. Now in the empty space, you will write this b, but you must divide by 2. So this is the pattern. Alright, and what we have just done is actually complete the square. This is the technique. So let's look back at our learning target on the top. Have we observed a pattern to derive a method to complete a square? Yes, we did. Okay, so let's check it off. In fact, let's turn one page in advance. We have done this already. Actually, we have done this. I can complete the square for the form x squared plus bx. Okay, let's move on. Let's go to page 3. Now for page 3 and page 2 are very similar. The only difference now is instead of a plus, 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 now you see minus, minus, minus. Now how is it different? Let's see the first example. And I will go through very fast after this because the logic is the same. For the first question, x squared minus 2x plus 1 squared. A reminder, 1 squared is just a 1. If you were to apply this technique, the cross factorization method, you will see that the result is x minus 1 times x minus 1, and we know that because they are the same, when they multiply together, they will get x minus 1 whole thing squared. And here, I'm basically copying over what we have, and I'm going to make x squared minus 2x the subject. Make x squared minus 2x the subject. What do I notice? I will still balance the 1 squared over, and that's how I got negative 1 squared. Now repeat the exercise for the next few questions and check the answer in a short while, and then we'll observe a pattern. Alright, you can now resume the video, and we are now going to make subject, 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 and subject. But take into account, we are currently dealing with all the minus cases. Minus cases. So, please check that what you get for part 2 should be x minus 2 whole thing squared minus bracket 2 whole thing squared. Next one, x minus 3 whole thing squared. Sorry, pardon me for the handwriting. Minus 3 whole thing squared. And the last one is x minus 4 whole thing squared minus bracket 4 squared. So, what's the pattern? The pattern is this. X squared minus 10x equals to what? X squared minus 12x equals to what? X squared minus 28x equals to what? And x squared minus 5x equals to what? So from what we have understood about the pattern, you should be able to write all of them as x, 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 and because it's minus, you will write minus, 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 minus. The next digit will be 10 divided by 2, 12 divided by 2, 28 divided by 2, and 5 divided by 2. So 5, 6, 14, and 5 over 2. Close, close, close the brackets and square them. And that is not complete. You must have a bracket squared, subtract it, minus bracket squared, minus bracket squared, and minus bracket squared. Now what number goes in? 5, 6, 14, and 5 over 2. So basically it's the same logic as the previous page, just that the only difference now is there is a minus here, which results in this minus. So, for positive and negative values of b, we can now conclude, okay, that x squared plus bx is x plus b over 2 whole thing squared minus b over 2 whole thing squared. Now this is for b when it's positive. Now when it's negative, there is only one slight difference. We will say that when, let's say there's a minus, this will be a minus. Okay, minus and minus. But this one is always minus. Okay, so with that, we have finished the first learning target, or rather the second learning target. Can you add in on your cover page? X squared minus plus and minus bx. Okay, we're covering both cases, both for the plus and the minus. The result is actually x plus, sometimes it can be minus, depends on the situation, b over 2, b over 2 whole thing square minus bracket b over 2 whole thing square. So we have achieved this learning target. Okay, I will end the video for this part.